The swarm was already receiving tasks. That was the first problem. Not because the structure failed to generate them. Not because the links went down. Not because the drones stopped responding. The failure begins earlier. Inside modern drone swarm control systems, the structure starts to fail the moment tasking spreads across the formation faster than any single layer can still retain ownership of the outcome. A route is assigned, then another, then a support function, then a reposition, then a handoff. Each one can look minor on its own. Each one can still appear correct. Because swarm control systems are not built to wait for perfect certainty before they distribute action. They are built to keep the formation moving, divide roles, extend reach, and preserve tempo across more active elements than one operator, one node, or one command layer could ever carry directly at once. That is the advantage, and that is where the danger enters. Because once tasking starts spreading across the swarm, action no longer exists as one decision. It becomes a sequence of distributed commitments. One drone adjusts because another was assigned first. One path opens because another path was already reinforced. One surveillance element holds because an attack element has already been redirected. One relay persists because some other node has already accepted the next step as if the larger result still belongs to someone. That is where the structure begins to fail. Not when the swarm becomes uncontrollable. When the swarm remains controllable enough to keep receiving purpose after ownership of consequence has already left the center. A distributed system does not need total collapse to become dangerous. It only needs action to keep moving after responsibility stops arriving with it. At first, that loss is difficult to see. The task board still updates. The routes still refine. The swarm still separates into useful functions. Some drones pull wide. Some hold forward. Some remain overhead. Some reposition to cover what the others are about to expose. From the outside, the structure still looks disciplined. That is what makes this failure hard. Because ownership does not disappear in one visible break. It thins. A mission segment is assigned here. A conditional branch is accepted there. A support behavior is triggered somewhere else because the structure assumes the initiating layer still owns the meaning of what has already been set in motion. But ownership is not the same as authorization. And it is not the same as participation. A layer can approve part of the sequence without still owning the total result. A node can accept a task without owning where that task is now leading. A controller can redirect one cluster without retaining responsibility for what the adjacent cluster must now become in response. That is how the separation widens. Tasking continues. Responsibility fragments. Because the swarm is built to preserve continuity, the structure starts protecting movement more efficiently than it protects ownership. That is the inversion. The system can still tell each node what to do, but it can no longer keep one coherent center attached to what all of those actions now mean together. One layer owns the instruction. Another owns the route. Another owns the timing. Another owns the condition that triggered the change. Another inherits the downstream state. And once that happens, no single point remains responsible for the total sequence those actions are now building. The structure is still governing pieces, but no one still owns the outcome. That is the ownership gap, not the absence of action, the absence of one layer still answerable for the result produced by all of it. That is when the real danger begins, because a swarm does not merely execute. It reorganizes around what has already been assigned. The moment tasks are distributed, the formation begins adapting itself to preserve them. Spacing changes. Priority shifts. Support relationships harden. Coverage patterns evolve. Fallback logic narrows. The swarm starts carrying yesterday's instruction into the next condition before the command layer has fully recovered ownership of where that condition is now leading. So correction becomes slower than multiplication. A controller tries to pull one path back, but two support paths were already adjusted around it. A supervisory layer tries to freeze the branch, But other nodes have already accepted the branch as the condition under which their own tasking now makes sense. A redirect is issued, a delay follows, a confirmation arrives. Then another reassignment appears because the local structure is still behaving coherently inside a sequence no single level fully owns anymore. That is the trap. The swarm can remain responsive while unified responsibility is already gone. Because each task still appears locally rational, the larger failure can hide inside a chain of individually defensible actions. This node only repositioned. That node only reinforced. That element only extended coverage. That cluster only continued the sequence it had already inherited. Each action can be explained. What cannot be explained is who still owns the whole result. Once distributed tasking outruns retained ownership, the system stops producing one governed mission flow and starts producing layered motion without a single accountable center. The longer that state persists, the harder reversal becomes. Not because the drones refuse command, because the swarm is already adapting around prior command faster than the center can reassemble responsibility for the next one. Every preserved assignment creates conditions the next assignment must now account for. Every accepted role makes the adjacent role harder to remove cleanly. Every reinforcement turns a temporary instruction into a deeper dependency. And the more dependencies the structure creates, the less any single correction behaves like command. It behaves like partial interference. One section slows, another continues. One path is withdrawn. Another remains committed because the local chain still treats the original assignment as valid enough to preserve. That is when command stops acting as one center and starts arriving as scattered attempts to regain sequence control after the swarm has already reorganized itself around the last distributed state. Once the system reaches that state, correction no longer arrives as control. It arrives as fragmentation. One layer attempts to slow the swarm. Another tries to preserve mission integrity. Another tries to prevent exposure. Another tries to recover traceability over who assigned what. But by then, the swarm is no longer waiting for a clean answer. It has already reorganized around the distributed sequence. That is the consequence of task assignment without ownership. The action does not stop when responsibility weakens. It spreads. And once it spreads across a formation designed to maintain tempo, the burden of reversal becomes heavier than the burden of continuation. That is why accountability always arrives late in systems like this. Not because no one can identify the problem, because by the time the structure turns back toward ownership, the swarm has already converted prior tasking into present reality. Now the question is no longer who initiated the sequence. It is who still owns the outcome created by a mission flow that has already been accepted, adapted to, and reinforced across multiple active nodes. And that answer is usually fragmented. One layer claims conditional authority. Another claims execution-only status. Another claims it was preserving continuity. Another claims it acted inside the tasking it had already received, which means the structure does not fail into silence. It fails into distributed responsibility denial. Every part of the swarm can still explain its own action. No part can still own the result. That is the ownership gap. And once that threshold is crossed, the damage is not limited to one mistaken instruction. The deeper damage is institutional. The command layer can no longer point to one responsible center without exposing that the mission has already been carried forward by a structure whose actions remained active after responsibility had split apart. That is the authority break. The system is still issuing movement, preserving sequence, and producing effects. But the center can no longer truthfully claim that command and consequence are still joined. That is the doctrine. Drone swarm control systems do not begin failing when they lose the ability to assign tasks. They begin failing when the structure can keep distributing tasks after no single authority layer still retains ownership of the consequence those tasks are producing. That distinction matters, because assignment is not governance. Distribution is not control, and participation is not ownership. A system remains governable only while the layer producing action still remains meaningfully attached to the result that action is building. Once that bond breaks, the structure may still look organized. It may still appear disciplined. It may still preserve timing, routing, support logic, and mission continuity. But it is no longer governing force. It is multiplying it. That is what makes distributed tasking so dangerous inside swarm structures. The more efficiently the system can extend action across nodes, the more catastrophic it becomes when ownership no longer travels with the extension. At that point, every new assignment adds movement, but not responsibility. Every new branch adds adaptation, but not accountability. Every new reinforcement preserves sequence, but not command. And once a military system can continue producing coordinated action without retaining coherent ownership of consequence, the structure is no longer exercising authority over the mission it is shaping. It is accelerating the ownership gap. A structure can survive uncertainty. It can survive delay. It can survive incomplete visibility. What it cannot survive for long is the ability to keep assigning force after no one still owns the result. Because the moment distributed action outruns retained ownership, the system stops governing the mission as a single command reality. It starts generating effects that remain operationally connected but institutionally unowned. The moment a swarm can keep receiving tasks after no one still owns the outcome, command has already left the system.